Welcome to the On-Premise IT podcast, the only podcast that dares to be both on topic and on location. My name is Tom Hollingsworth, and I'm a part of Gestalt IT. In each episode, we bring you the perspectives and opinions of a group of IT luminaries, experts in their field, and we pick a topic, a premise, to debate. I'd like to take a moment for our panelists to introduce themselves for this episode before we jump into the premise, starting with Jody.
Hi, I'm Jody Lemoine. I'm an independent IT consultant working in the Niagara region of Canada.
Ben Young, I'm from New Zealand, work for a cloud service provider. You can find me online at Ben Young NZ.
And Bart Heungens, based in Belgium, also an independent IT consultant. You can find me on bitcon.be.
All right, thank you all very much for joining us. Let's jump into this episode and its premise. We've talked a lot about edge computing over the course of 2023 here at our Gestalt IT and Tech Field Day events. And we talk a lot about the need for edge computing, the need for high-speed edge networking, the possibilities of doing AI at the edge. But as Ben mentioned when we were doing the discussion for this, nobody ever talks about backing up the data at the edge. We keep a lot of stuff out there that we're going to do work on, but we never worry about what happens to it if, I don't know, the cellular base station gets hit by lightning or someone comes in and just decides to clean out the supply closet when we're not paying attention. So the premise for this episode is nobody ever talks about backing up data at the edge. Ben, you started this mess.
I did, yeah. I mean, and even probably equally important, how do we restore data back to an edge? You can probably get the data out, trickle it out, but how do we get it back in a hurry, and what's the order of things? And I think, we rewind to Edge Field Day 1, there was a lot of talk about centralized orchestration and zero-touch provisioning and having things shipped directly from a hardware supplier back to the store or the solar farm or whatever it might be. But all well and good for a greenfields deployment. What if there's already data there? Do we need to back that up? How are we backing it up, and how do we get the data back on there if it needs to be replaced at any point? And that hasn't really been touched. So I guess the question is why? Do we need to protect data at the edge? Do we design applications that just don't need to have that happen, or is there a gap in the market that we need to fill, and how do we fill it? Would be my kind of opening comments on that.
That's going to depend a lot on the application and what you're doing at the edge. Sure, you've got things that are transient in some applications. You've got things that absolutely need to be there in others. How much data changes the whole thing. If we've got a whole ton that we can't pull across those connections, well, now we got to come up with an interesting solution. Or maybe you just want to real-time stream it back to a cloud.
Yeah, or it could still be protected on the edge, right, with a different appliance. We've talked about lots of devices that run the edge compute and the workloads and the applications that are out there. There's no reason why we couldn't take the sort of more traditional IT model. Sure, it's not necessarily going to be off-site because of those connectivity restraints or whatever it might be, but at least it's not on the device that might have melted, fallen off the back of the tractor or whatever it might be. Yeah, what sort of things? Are we missing a device? Is that what we're missing?
Well, again, I agree. It depends on the data and the application. If it's video images that you're collecting and you're running the analytics on it, and then you get the final data, you send it over to a database, then this data of a license plate of a car or whatever that you're catching up at that moment, do you need to keep it for regulations, for proof, or is it okay that I analyze the data, I delete it, and I take the next picture to analyze? So for me, it depends on the application and situation.
Mm-hmm.
It also depends how you're defining edge. Like, we've talked about edge computing ranging from anything from a container on a little ARM device just taking care of tiny little things that you have at wherever you have things, all the way up to 61 terabyte storage solutions and some AI thing going on that's likely to wake up and hunt Sarah Connor tomorrow. But what you do depends on where that is, or on how critical it is. So if you've got something reasonably big, you can kind of use an old school solution. You got cloud over here, but before we had cloud, we just had local compute. How different is local compute from edge? We used to back up our servers that we had on premises because our servers were on premises. Well, we back up our edge, same way. It's the same idea.
Yeah, and probably the bigger the edge, the more traditional tools we've got available to us, the backup vendors that integrate with hypervisors or in-guest agents. But the more bespoke they get, the more inbuilt into a car or a tractor or whatever it might be, that's unlikely to be able to run traditional kind of backup tooling.
Or at least not enterprise tooling.
Yeah.
Because now we need to check as well, if you take a look at the traditional data protection with the daily, weekly, monthly, yearly schemes, are we going to do the same thing then at the edge? But will it be minutely, hourly, also daily or weekly? And then you want to keep a copy locally. We're going to put a NAS or a tape drive or something also on premises, and then an additional second copy in the cloud.
Yeah.
But then again, is it still an edge solution, or is it becoming part of a cloud at that moment as well?
Are the two mutually exclusive? They don't have to be.
No, not at all, but it can be, because if you have that 60 terabyte data in that example that we had, if we need to move all that data as well to the cloud, well, why do we need that edge at that moment? Just grow your cloud and put some compute over there, and then it becomes an whatever on-premises cloud solution.
So it's fascinating that you talk about this idea that the edge can be a lot of different things. Because a lot of times, as we've learned at this event, a lot of times when we say edge, we are thinking like IoT. We're thinking about sensors. We're talking about those kinds of things. But then we talk about enabling tractors and other stuff, or creating citywide networks that are doing data collection and stuff like that. But I thought it was interesting that you brought up the fact that we used to do this with local compute. Well, for a long time, yes, we would back up data from a server, but we wouldn't back all the data up because the operating system can be reloaded. That's fairly quick. What we cared about was the data that could not be easily replaced. And it took us a while to identify the data that needed to be replaced. Well, in a lot of cases, these IoT devices have, standard images that either live on the device and can be quickly refreshed, especially if you're talking about something like a containerized system where, the base operating system just doesn't get touched. Do we need to be doing a better job of isolating the data that lives at the edge so that it can be easily backed up, or is in a situation where it can be made more persistent? I mean, I hate to say it, but do we need to start doing things like installing small SANs next to our compute nodes so that it's easier to keep the data in one spot that's easy to just back up in a single pass?
Yeah, I was just thinking as you were talking, like an edge could be a research vessel that it's out at sea for 3-6 months with, at a high cost per week or day to run. If they have to rerun, seabed scanning or whatever they're doing out there, very high cost. So I wonder what the architecture looks like on something like that. It obviously has big financial implications if you lose the data. Are they running something like a backup on the ship? Sure, it's not going to necessarily transit the ship until it gets into port, but at least they've got a secondary copy if the primary's corrupted. Or have they gone that route of a super resilient storage array or storage system like an object store that can handle multiple disk failures and things, and that's the way that they're dealing with the protection of data at the edge until they can copy it off, I wonder.
And we see the same thing with something like an Airbus A380. It generates a lot of in-flight data, but there's no way to get those gigs of data off the plane until it lands. And then all of that data is ingested and effectively backed up at the same time. And the only time you don't get the data back is if there's a problem that, well, let's be fair, maybe the data would have told you what was up. But, when you think about the amount of data that can be generated on the edge somewhere, like a research ship, an airplane, a research station in the middle of Antarctica, that the applications that you have for these kinds of things are non-traditional. Like, not every place has a data center. Not every place has the space for a data center. I mean, one of the edge applications that I've seen is putting things in in delivery vans so that it's easier, more efficient to, check off package deliveries and things like that, so that you don't need to have constant network uplinks to do real-time data feeds. Maybe it checks in every hour or something.
But then we can open up the discussion for data protect. If we take in general about data protection is making a point-in-time copy and move it somewhere else. So if we lose data, then we can recover it. Maybe we can open it up, because if I have indeed that ship that is out for multiple months, then we might take a look maybe at high availability solutions, that we have some kind of a cluster with a failover, or let's say that operating system that you say, okay, it's maybe a containerized application, it's completely stateless, and so if I reboot it, it spins up again, but maybe they have other operating systems where I might think that, okay, I'm gonna implement RAID 1 on those SSDs to run that operating system and the application, and maybe not install one device, but a cluster of 2 devices. If something fails, at that moment it fails over as a second to the second node in that cluster, so that the application stays running proactively before the data got lost. But then we're talking about, and then again, what is the edge solution? Is it that little Raspberry Pi, or is it indeed a true server, a ruggedized server? But at that moment, do we need to implement clustering as well, maybe? Because for me, at least, this is also a part of a data protection solution.
Maybe we should invent a product called Towboat, and we'll sell a service to boats that go out, and we'll just tow it behind as a sort of off-site copy.
We'll throw the tanks out there so
Yeah.
that they have a safe place to be.
Yeah, that would be a great idea.
What we're learning as our concept of edge expands. Like when I came here, I thought, oh, tiny little IoT stuff, and now it's getting bigger and bigger and bigger. You could almost define it as not cloud, which means really our requirements for data recovery and data protection are as varied as they were before we started moving to the cloud. It depends on the application, depends on the environment, could be an enterprise solution, could be a tiny little Linux solution. But edge is kind of what's left after we've done the cloud migration. Admittedly, we've moved on to smaller applications like vehicular networks and the like. But just about everything that is physically tangible is being defined as edge now. And so it creates a much bigger, like we can't just say, how do we do data protection at the edge? Because it's a big category.
Yeah, it's funny, like you mentioned, like anything that's not cloud, but then definitely what we learned from the first Edge Field Day was these edges are almost identical to clouds. They're running Kubernetes and a bunch of other stuff. The orchestration is the same, infrastructure as code. All these things that we use today to construct modern cloud architecture is being utilized at the edge, which again enables us to actually protect them in a way, in the same way, but often it's that offsite copy. How do we get the data there?
Well, but going back to that, we did a roundtable here at Edge Field Day, and one of the things we talked about is that cloud isn't necessarily like, a data center in Reston, Virginia. It's an operational model. It's a way of deploying things quickly and iterating, with less friction. And so that's why a lot of IT has started to look like that. I mean, that's effectively what private cloud is it's taking on-premises equipment and applying cloud methodology to it. So is there a way to take that cloud methodology, the idea that we think about redundancy and resiliency, and implement it on-premises to create a kind of cloud-like structure that ensures that our data is being at least taken care of? Because everybody out there will tell you, oh, well, yeah, I back things up to the cloud and everything works out just fine, until it doesn't. And then, the day that your backup stops working is invariably the day that your device is going to break and you need something off of it. How can we use the cloud or the cloud structure to enforce the kinds of, recovery options that we need?
Well, that depends on your bandwidth.
That's only if we're talking about getting it off-site, right? Like it might be just that we need to deploy more hardware to the edge. We've nailed it down in terms of the number of devices and the sizes and how much storage we can have there with graphics cards or whatever it might be to run the workload. But maybe we're just missing the piece of we also need to deploy a backup server. And that might not look like a traditional backup server, but it might be something similar to a backup server that can run those same sort of tooling that we're used to and can back up those traditional cloud workloads today.
And honestly, I think we're kind of at the point in our lives where anything that can have like a 5G card in it is going to have it, and we're going to back up as much data as we can over that because we have persistent connectivity. But like some of the examples we've already given, not every edge has universal connectivity. Even in the US, I mean, anyone who's ever flown into the Denver airport knows that as soon as the plane pulls away from the gate, you lose cellular connectivity until you're out on the runway. And so, some things can go wrong on the taxiway and you don't have the ability to upload that data. Or worse yet, what happens if you're in a situation where something goes belly up and you need to recover? Can you stream that data back? I mean, look at Amazon Glacier. Glacier is effectively write once backup. We never want to get that data back because it's effectively free to store it, It's not so cheap to restore it.
Yeah, and like, how do we slot that recovery process into the provisioning process or the deployment? Sure, we can order a new server and say, deploy that image with that persona or whatever, and it gets down to the edge and connects back up and it goes, hey, I'm a point of sale system for this store. It knows what it needs to orchestrate on premise. How do we get the data that was in the backup? How do we make that part of the provisioning process? Is it that we, by default, pull it down, over the internet? In some cases, that'll work if it's got the bandwidth available, or do we need to have it kind of almost break our model of going straight to site where it comes to IT first, or a central place with connectivity can connect in and do that first step before it kind of ends up at its final destination? It's kind of an extra hop, but it's also not a greenfields deployment, so it's slightly different.
And cost effectiveness is a consideration too. Speaking as the Canadian here, where we've got some of the highest data costs in the world, if you're spending $2 a gig to transmit stuff, and you've got a 61 terabyte RAID that you're that you're wanting to repopulate, well, that's going to be a very expensive proposition.
And also the time that it will take, because 60 terabytes, as an example, it's really a lot of data to have that copied somewhere and then get it back as well.
Even in the data center, right?
Even in the data center, we need 10, 2500 gigabit networks. You cannot imagine that at the edge.
No.
The edge being outside that data center, right?
Not 5G for sure.
So 5G, 6G, 7G one day, it will never happen, by the way.
Or something like Starlink, right? Is that going to enable
even
more
then,
possibilities with this? Like even on a boat example, right? There's obviously no cellular connection out in the ocean, but I have seen them advertising specifically for cruise ships, or if you own a big super yacht or whatever, you can stick a Starlink dome thing on the top of your boat and get on Instagram or whatever you need to do on your boat.
You can for a reasonably, reassuringly expensive fee, because it's one thing to have a Starlink or other satellite solution at a fixed point in the US, but as soon as you start moving it, they know, and they're like, oh, you want to move it? That's going to cost you more. And that's one of the challenges, is that the people who have these needs usually have budgets too. And so that's why a lot of these solutions kind of look pricey. It's because if you need it, you're going to pay for it. And that's unfortunately the way that the IT works, is, this is going to cost us a small fortune, because, like Bart said, even in the data center, we have relatively ridiculous speeds. And if you need a 100 gig switch, you have the budget for a 100 gig switch, and you're going to buy it. And so they know that, and they're basically trying to, get their return from those companies. But I've also seen a lot of delivery vans, oil rigs, that kind of stuff, who's running off of 10-year-old hardware, because it doesn't need to be fast. It just needs to not blow up.
there you go.
So I guess coming back to the original question, if nobody ever seems to think about backing data up at the edge, what should people be thinking about? How should people be looking at this if they listen to this podcast episode and are already freaking out because they realize that if their edge compute devices go down, they lose everything?
I think at a bare minimum, they need to define what their applications are. Much like traditional IT, we look at systems and go, what's the RTO, RPO? We start looking at the cost-benefit analysis of all of those things and look at what's at the edge, what's at stake if we lose any data, what's the business impact, all these things, and start looking at it like that. And then we can start solutioning based on that, because obviously different RTOs and RPOs will have very differing costs.
When I started a discussion about data protection with the customers, is what's the cost of downtime? Mm-hmm. What's the impact indeed of when you don't have access to your applications and your data anymore? Well, what's the impact? How many people are impacted? How many money do you lose every minute, every hour, every day? And I think for that edge location, let it be an IoT device or a car or a boat or whatever it may be, how much does it cost, or what's the impact? Will there be people who will be dying, or what's the impact if you don't have that data anymore? And I think at that moment, we need to find the right solution to have a copy locally, or maybe have a copy elsewhere, because that was just one thing that I was thinking about. We have that best practice, that 3-2-1 rule. Now, are we going to apply that 3-2-1 rule as well at the edge location? Because then we have 3 copies indeed on 2 different media. So that means as well that we need, some kind of another solution
You're
with
missing
another
the-
technology.
Missing the 0, 1 immutable copy, right?
And also an immutable copy, indeed, but that should be a checkbox in the software, but nevertheless. Or are we really going for a tape drive and there's an individual that needs to get that tape drive out of...
Again, cost benefit, right? Like cost per gig of tape can't be argued, right?
I see a lot of opportunities
Yeah.
out
And well,
there.
it sounds like an AWS-y kind of name too, so I'm sure we could sell Towboat to them.
Yeah, I think so.
But the towboat is kind of a extreme idea, but if you look at the idea of just an armored storage case, something that is lockable, sealable, waterproof, put that in a car, put that on a boat, put that whatever. It's basically a micro SAN. And all the redundancy you want, put your 3 copies in there. Depending on how much data you're doing, you can have a storage manager right in the box. And then any of your working components can slave off of that with fair confidence that it's going to stay running no matter what. That might be our answer.
Definitely.
Cheaper than another boat.
For sure.
So I think that we've kind of discussed the pitfalls of edge computing when it comes to what happens when you need to protect your data. I mean, I can cite you examples of the pets versus cattle argument. We can talk about why you don't want to keep your data in places that it could possibly be destroyed. You can talk about the security implications, but the end of the day is on the edge, things don't go perfectly every time. Cables get unplugged, things happen, electrical surges occur, and you're going to lose data. Anybody who claims that they're not has obviously never had to do a restore. The edge is no different than any other computer that you own, whether it's in the cloud or on premises, and you need to provision to save the things that are important. Maybe the data isn't what's important, it's the analysis that you want to keep track of. If you don't have reliable connectivity at the edge, you need to come up with a better solution to make sure that that happens, even if it's just stuffing a parallel port zip drive underneath the system and hoping that somebody changes out the disks every once in a while. No matter what it is, though, you need to start thinking about it now because you don't want to have to think about it after the data's gone. That'll just about do it for this episode of the On-Premise IT Podcast. We have a new episode about every 2 weeks. You can subscribe to our YouTube channel, youtube.com/Gestalt IT video, or just head over to gestaltit.com/podcast for the information on the latest episode. We also publish these in our podcast feed. Just search for On-Premise IT Podcast. And yes, we are using on-premise correctly here. We'll be back with another episode in just a couple of weeks. Until then, take care of yourself and remember, stay on premise.